Hey everyone, good morning. I am Priyanshi Agrawal and welcome back to my YouTube channel. Now we are going to see today's Leetcode daily challenge, which is minimum equal sum of two arrays after replacing zeros. Okay, so let's see what is this question and how we can solve it. So in this question, you are given two arrays nums1 and nums2 consisting of positive integers. Okay, you have to replace all the zeros in both arrays with strictly positive integers such that the sum of elements in both the arrays become equal. Okay, and you need to return the minimum equal sum you can obtain or -1 if it is impossible. Okay, so what you have been given in this question is two arrays nums1 and nums2 consisting of positive integers. It means it also contains zeros as well, and you need to replace all the zeros with some positive integers such that the sum of both the arrays become equal, and you need to return the minimum equal sum. Okay, so for returning the minimum equal sum, we need to replace the zeros. So to get the minimum sum, 0 should be replaced by a minimum positive integer, right? And the minimum positive integer is 1. Okay, so let's say if we replace all the zeros with 1s, okay, because we need to return the minimum equal sum, so we are replacing all the zeros with the minimum positive integer. Okay, now let's do the sum of both the arrays. So let's say sum 1 is equals to 3 2 5 6 7 8, right? And sum 2 is equals to 6 5 11 1 12. Okay, the sums in both the arrays are not equal. The sum of both the arrays are not equal if we have replaced all the zeros with ones. But we can find the minimum equal sum by replacing all the zeros with the ones. How? Let's say. So both the arrays have zeros in this test case. It is not guaranteed in the question that both the arrays are going to contain the zeros. It is not guaranteed in the question. It can or it cannot. Either one of them can contain zeros, or both of them contain zeros, or no one of them can contain zeros. So in this case, they both contain zeros. Okay. So let's say if they contain zeros and we have replaced all the zeros with the ones and their sum are this. Okay. So if they both contain if they both contain zeros, then it means we can obviously increase their values sometime in the future, either 1 to 2 or 3 or 4, anything, right? So even if their sum are not equal, we can get the minimum equal sum. So the minimum equal sum is going to be the maximum of both of them, which is going to be 12, because we can obviously, the difference is 4. So let's say if we have increased this 1 to 5, let's say if we replace this 0 with 5 and this 0 with 1, and the sum will become 5 10 11 12, right? So even if their sum are not equal, we can get the minimum equal sum because they both contain zeros, and right now we have replaced them with ones, but we can also replace them with any value if we want to make their sum equal. So to get the minimum equal sum, we have replaced all the zeros with the ones, and the maximum of both of them will give us the minimum equal sum, which is 12. Because in this we can replace 1 0 with 5 and 1 0 with 1 to make the sum equal to 12. And here answer is also 12. Right? Okay. But let's see another test case as well in which it is not possible to make their sum equal. Let's say this test case, which is 2 0 2 0 and nums2 is 1 4, right? Okay, so let's see this test case. So let's say we have replaced this 0 with 1 and this 0 with 1. Cool. Now its sum will become 6 and its sum is 5. Okay, so can you see in this test case that this array doesn't contain any zeros? So even if their sum are not equal, what we were deriving from this example is the maximum of both of them is going to be the answer. Okay, so if we take the maximum of both of them, then the answer will become 6. But in this test case, nums1 also contains zeros, which can be replaced with some greater value. That's why the maximum value was the answer. But in this test case, the nums2, which have lesser sum, does not contain any zeros. It means we can't increment its sum above 5. We can't. So that's why in this case it is impossible to make their sum equal. So we will return -1. Right? Okay, so what we can derive from here is that what we will do, we will simply replace all the zeros with the ones in both of these arrays and calculate their sum. Let's say it is 6 and it is 5. And we will check if, let's say this is sum 1 and this is sum 2. Cool. So what we will need to check, we will check if sum 1 is greater than sum 2. It means sum 2 should have some zeros, right? The array whose sum is less should have some zeros so that it can be made equal to sum 1, right? If it is not, then it means we can't make their sum equal. So if someone is greater than sum 2, and let's say we will also keep track of some variable 0, 2 is equals to 0 and 0, 1 is equals to, let's say 1, because it contains 0, so that's why true, and it doesn't contain any 0, that's why false. So we will also check if 0, 2 is equals to 0. It means the array whose sum is less and it also doesn't contain any zeros. It means we will return -1. We can't make their sum equal. Or other condition can be if sum 2 is greater than sum 1. It means nums 1 should contain some zeros. If it doesn't contain, let's say if it doesn't contain, then we will return -1. And otherwise return maximum of both of them, maximum of sum 1 comma sum 2. So this is going to be the approach for this question. We can return maximum of sum 1 and sum 2 if they contain zeros. If the sum of 2 is less than sum 1 and nums 2 doesn't contain any zeros, it means we can't make sum 2 equals to sum 1, because sum 1 is the minimum sum which we need to make their sum equal, but see, sum 2 can't be made equal to sum 1 because it doesn't contain any zeros. Similarly, if sum 1 is less than sum 2 and it doesn't contain any zeros, then we can't make sum 1 equal to sum 2, so we will return -1. Otherwise, we will simply return the maximum of sum 1 and sum 2. Okay, so let's try code this so that we will get a better idea. So let's say we will initialize two variables, sum 1, sum 2, and let's say we will also initialize two variables, zeros 1 and zeros 2, and now we will iterate in our array I is less than nums1 dot size to calculate the sum I plus plus. We will sum 1 plus is equals to nums1 of I, and if nums1 of I is equals to 0, then what we need to do, we will set this flag to 1 and we will also replace it with 1. It means sum 1 plus is equals to 1, or we can say sum 1 plus plus, right? And now similarly we will do for the nums2, I is less than nums2 dot size I plus plus sum 2 plus is equals to nums2 of I, and similarly if nums2 of I is equals to 0, we will set that flag to 1. It means it contains zeros, and sum 2 plus plus, it means we have replaced that 0 with 1. Now we will check if sum 1 is greater than sum 2 and nums2 doesn't have any zeros. It means we can't make their sum equal, so we will return -1. Else if sum 2 is greater than sum 1 and nums1 doesn't contain any zeros, it means we need to return -1. Otherwise we will simply return maximum of sum 1 and sum 2. Cool. Let's try run this. Yeah, it's working fine. Let's try submitting it. Yeah, it's working fine. So now let's talk about its time and space complexities as well. So as you can see in the question, we are first iterating in this first nums1 and then nums2. So its time complexity will be big of n1 plus n2, where n1 is the size of the nums1 and n2 is the size of nums2. And as we have not used any extra space, So its space complexity is going to be big of 1. So yeah, that's all for this question. I hope you get it, but if you still have any doubts, then you can post in the comment section. I will surely try to answer them. Till then, bye guys, see you in the next video.